Hi, everybody. Thank you all very much for joining the third part of this webinar, of the series of webinars that relate to the actual articulator. And before getting involved in the actual third part, I would like to go through a quick overview of what was done in the first and the second part. We started off by introducing the articulator, its elements and its components. We spoke about the reference planes that are within the system. We took a look at the reference objects, which we usually utilize as references when we are mounting the models into the articulator manually. And we went through an actual manual mount where we determined the midline by locating the midline seam and utilizing the midline plane. That plane actually falls right in the middle of the articulator, so it's pretty important to detect it correctly. We placed the model within the articulator by utilizing the plane finder, and we determined the distance of our reference point, which is our first motor to the hinge axe. And in the specific PS1 articulator, it's 90 millimeters, and we used the ruler to find this measurement and the pitch of the actual upper model. We determined that by utilizing the plaster plane, and we set it to a medium pitch, which is around about 6 and 7 degrees. And the models were mounted manually in the articulator, and we performed a functional evaluation of the teeth surface, and we had an idea of more or less what the function was in relation to this specific type of setup. In the second part, we added the face hunter and the plane finder, and we introduced the concepts of the natural head position. We located the ala tragus plane of occlusion, and we mounted the models in the physical articulator according to the philosophy of the plane system. And then we integrated the face hunter, and by integrating the face hunter, we digitalized the workflow. We produced all the face images of the patient. We located the natural head position by utilizing the image that we took when the patient walked up to the actual plane finder, and we determined the ala tragus by utilizing the patient's portrait, and mounted the models in the articulator by matching the face transfer fork to the model. And then we matched the markers to the face transfer fork image and aligned the models to the face, and mounted the models in the articulator by locating the midline center of occlusion. And the models were mounted according to this specific data. Now, today we are going to integrate the third element, and that is going to be the Plane Analyser, which is an assiograph designed to analyze and record jaw motion, the data necessary to set appropriate values to the articulator, and it also allows computerized recordings of all the specific movements. The Plane Analyser is comprised of an upper bow that's fixed to the patient's head, and within the bow are embedded the upper receivers. The lower bow is connected to a fork that is fixed to the lower teeth, and the sensors are embedded within the lower bow. These sensors measure the travel time of ultrasound impulses in order to deliver specific recordings. The actual report that we receive from these recordings relates to the sagittal condyle left and right, the inclination of the eminence basically, the right and left Bennett angle, the retrusive movements, the immediate side shifts, and the frontal table inclination. It delivers also graphic reports that we can analyze and visualize in order to physically see if there are any specific internal derangements of the TMJ. And what I would like to move through now is just to go through a quick setup of the Plane Analyser. So we're going to show you a quick little video and show you how easy it is to set it up and to go through the actual movements. And here we are. We're back on board, and I'm really pleased that we made this little video to show you how easy it is to set these bows. It doesn't take more than 5 minutes, and to perform the recordings, it's another 5 minutes. So the operation lasts more or less around about 10 minutes, and just 10 minutes of our time, we can get perfect data to set up our articulators and make sure that whatever we're going to go through is as accurate as possible. So we are back here to the software, and we basically start off from the first part of the articulator, where we set everything up with standard values, and we performed our functional movements to see if there are any pre-contacts during the movement themselves. So now what we need to do is just to try and remember the contacts that we visualize while we perform the movement. So we are on the right side, we're moving down. We can see that the contact slides down the canine, and we make it a little bit bigger so we can see it a little bit better. And then at the first premolar, there's an interference on the first premolar, and it carries the load for quite a bit until the canine reaches it again. And then towards the end of the movement, towards the end of the border movement, we see that the lateral kicks in. So we're also going to have to evaluate the protrusive and the position of this tooth. And the reason why we started all this functional analysis was because we noticed that there was a little bit of recession on this tooth, and according to the movements that we are performing, this tooth is certainly taking up a bit of the load, and we are going to evaluate that in a better manner when we perform the same movements with the custom movements of the patient. Let's do the left side movement. We notice that there's a pre-contact on this molar while the canine is guiding the movement. The contact increases, it gets a little bit stronger, and at a certain point it just disappears, and the canine carries on taking the movement all the way through. If we evaluate the protrusive movement, we see that the canine helps, and at a certain point, two contacts come out on the first molars. They persist in the second phase, and then the lateral takes the movement and is taking it all the way up. So there's a lot of weight, a lot of load on that tooth until the central incisor takes the load. So these two teeth really do need to be evaluated. We are going to evaluate moving them around with an ortho procedure, but at the moment, let's just focus on the lateral movements. So we are now going to set the same movements with the custom data of the patient. Let me bring up my model. Here we are. So we have actually set it to the values produced by the Plane Analyser. Just let me open it up quickly so I can show you that. There we go. Okay, so we had on the left eminence, we had a 36.9. On the left Bennett, we had a 22.2. On the right eminence, we had a 41.8, and on the right Bennett, we had a 22.2. The immediate side shift was on 0. So based on that immediate side shift, the only insert that gives me a 0 movement is the gray insert. If we go back to the beginning of when we explained all these inserts, the gray inserts that are tied together, the Bennett and the immediate side shift. The gray one gives us a 0. The green one gives us about 1 millimeter of immediate side shift, and the red one gives us about 1.5 millimeters. So I wouldn't be able to use nor the green nor the red if my immediate side shift is 0. So my choice of this is the gray one, and also the eminence will be the gray one, and I set the values according to the gray eminence and set the angle to that position. At this point, we start the simulation, and now having custom data, we can actually compare it to the standard values. We are pretty close. There's not a huge difference between one and the other, but that small difference is what we are actually looking for, and it puts us in a condition where if we need to touch any tooth surface, we have accurate data that we can believe in, and making sure that whatever we're doing is done correctly. Just give it a minute so it can calculate. Here we are, we got it. Wonderful. And now let's just repeat those movements. Let me bring up my antagonist so I can have my contacts. There we are. And this is our starting point. The stop centrics are where they have to be. This is our starting point, and we start the movement. So 1, and we see that there is a contact appears on the first molar. 2, and we are more or less in the same position, or in the same condition as we were. But if you notice, the contact on the canine gets much lighter, and the premolar is taking a heavier weight with the custom data. And we carry on the movement. At a certain point, the premolar takes the weight completely, and this wasn't happening when we were performing the movement with the standard data. So there is a difference, and it's this difference that we need to focus on. There you are. So we have evaluated that. Let's go on the other side. At the first millimeter of movement, a contact appears on this tooth. This did not happen with the standard data. We carry on second millimeter. Canine takes the load, third, fourth, and off we go. So there's that's very, very small pre-contact on the working side in relation to the second molar. Okay, now I have faith in the data that I've received, so I'm going to perform a little bit of odontoplasty so I can eliminate this contact and see what happens and if it is steady. So this is the first one I'm going to eliminate. I'm going to make my brush a little small. I'm going to decrease the intensity, make sure that you don't use huge intensities. We just have to take away very, very small quantities. I'm going to make the brush a little bit smaller and just touch it as light as I can. And basically what we're doing is we're just changing the angle of this cusp. And we are good here. And I'm going to eliminate this contact as well. And again, what we're doing is we're just changing the angle slightly of this cusp. And off we go. The second. And now we get a contact on our premolar. So let's just fix this one quickly. Don't take away too much. Just take your time in doing this. It's important that we don't eliminate too much material. We have to be as sensible as possible when eliminating biological material. But everything is really very, very accurate and easy to find and easy to determine when we're performing these procedures on the articulator with our calibrated papers. It takes certainly much longer, and it's always very, very difficult to be accurate in what we're doing. And once we've taken it away, it's gone. We need another model to repeat the whole procedure. There you are. We're through now with the movement. Let me just open it up wide so we can check everything out. 1, and they are all gone. 2, 3, 4, and we are taking the complete load on the canine. I'm happy with that at the moment. Check the other side quickly. I remember a contact pitched up here, so let me take this one away. Now you're going to have to map all these touchings, right? You have to map them on a piece of paper. You can record them directly from your computer, so you can remember each single movement. Here we're doing good. That's the only contact. 1, 2, 3, 4, 5. Okay, it's not much. We're pretty close to what we're looking for. Now we need to apply whatever we have done. And we are now going to, I hope it doesn't freeze on me, bringing up some, there you are. Let me see if it's just a warning. Okay, and now what I'm going to do is I'm just going to repeat, let's say, the adjustment of the articulator. So it re-records the surfaces of the teeth, and it will tell me if there are still contacts that I need to evaluate. So working with these digital articulators is much, much easier than working with the actual physical articulators. I have a broad view of everything in relation to the mapping of the movements. And who does these type of procedures in the manual world or in the analog world really knows how difficult it is. And if you have to compare the two techniques, certainly you'll put your eyes on on how we can perform these type of procedures through a digital articulator. Got it. Let's flip it over. And we go again. 1, gone. 2, 3, that's back. 4, 5, 6, okay. So that means that we need to eliminate just a little bit more material. 1, 2, and we go ahead and we perform exactly the same procedure. Okay, it's a little bit too strong. I'm bringing it down to 11. Don't want to put too much. Okay, and I've got a contact here, which I really don't like. And off we go. Just a lot of weight on this premolar. This premolar was really taking a lot of weight. So I really believe that it's necessary that somehow this weight needs to be reduced. It goes on the canine. We are good on the motor. No other contacts are coming in. It's coming through okay. Let's check the other side quickly. 1, good, 2, 3, 4, and off we go. That's it. So the left side movement is pretty clear. We are good. I'm going to repeat it just to make sure that there's absolutely no contact on that premolar before we go ahead and do anything. Well, it needs to spin a little bit. Okay. Say yes. And we reactivate the movement. So this is the game. Do your touching, do your odontoplasty, and then you just reactivate the articulator in order for it to re-record the surface of the teeth. If there are any pre-contacts, it's going to bring them out, and then you're going to just touch them, and off you go. It's more or less the same as what we've been doing with in the analog world with our calibrated occlusal papers. I think that we are almost through. Maybe there's another little touching to do, but and here we go. I'm going to flip it over. My contacts are there, and we go. 1, 2, 3, 4. Just a little bit. Now you can see that the contact on the canine is starting to increase, so it's starting to take the load. There's that little pre-contact here. 1, 2, 3, 4. At the fourth millimeter, there's this little pre-contact. I'm going to take it away, and I still have a little bit on this molar here. 1, 2, 3, 4 here. I really don't like this contact, so I'm going to take it down. Extra. Modify. 1, 2, Where's it going? Here it is. See how small it is? But you can find it. And this little contact here. So these were the two major contacts that we actually dealt with. So I'm just going to smooth them out a little bit. And then if we perform this directly in the patient's mouth, and they will shine them up and make sure that they are nice and smooth. And I think that I'm through. Let me check it one more time quickly. Perfect. That canine is taking the complete load of the movement. The left is taking the complete load of the movement. I believe that I am through with everything. And I will say apply. Take note of all the touchings that have been performed. Create a sort of a map. Doctor will take care of those touchings directly in the patient's mouth, and then from there, go ahead and establish the second part of the therapy. So we do see that we have that the anterior region needs to be corrected slightly in order to get an ideal protrusive movement. The lateral is taking a huge weight of this movement, so the orthodontist will take care of this part. But in the meantime, what we are going to do is perform some odontoplasty and give at least the patient 6 months of time of assessment to see that whatever we have done is done correctly. And in order to do that, we are going to set up a bite. I'm not going to go through the actual procedure of creating the bite, but I'm bringing you to the final point on how I would like my bite to look like. First of all, your stop centrics need to be all in position. This is fundamental. Oops. Just let me make this translucent so we can see them. This is what I'm looking for. My stop centrics of my lower teeth are all hitting completely on my plane of occlusion. They need to be very, very well balanced. And these are the only contacts that I would like in the posterior region. What relates to the anterior region, I will set a contact more or less on every single tooth. Now, we are going to be doing some ortho, so I'm going to try and change the anterior arch in order to get the ideal protrusive movement of this patient. So during the period that he'll be wearing this bite, he'll start getting used to these movements, and we will have the opportunity to evaluate if there are going to be any issues in relation to the TMJ. Our lateral movements need to work like a Swiss clock. The canine needs to take the load, and everything on the posterior teeth need to be discluded. And the same thing happens here. As you can see, the canine takes the load. The bite is very smooth and very simple, but don't be fooled by its appearance. The value of this piece of plastic is really in everything we have done to get to this point and to make sure that every single dot that you see around the surface makes sense and has a specific function. Bites, or functional bites, usually have no reason to be aesthetic, but they need to be highly functional, and they have to deliver the functionality of what our future program is going to be for this patient. This is basically the whole therapy lined up in 3 parts. So what relates to the articulator, to what relates to the phases of odontoplasty and how we recover this information and improve it through the next phase. So I'm basically done with everything, guys. I hope you all enjoyed.